Alright, here's my first attempt at ever doing some sort of video or virtual lab. So you promised you wouldn't make fun of me. This part one, we're going to be reading page 110 in the book about energy and matter and how they're related. I'm going to be marking my text, so hopefully you have your textbook open as well as a pen or a pencil in your hand to put some metacognitive markers in the text. How are changes in energy and matter related? Do you feel as if you are full of energy today? Energy is the ability to do work or cause change. Every chemical and physical change in matter includes a change in energy. A change as simple as bending a paperclip takes energy. When ice changes to liquid water, it absorbs energy from the surrounding matter. Which makes sense, because if you think about it, in order for an ice cube to melt, or anything really, that's a solid or something frozen to melt, you have to heat it up, which means it's absorbing energy. When candle wax burns, it gives off energy as light and heat. We also saw yesterday and the day before and a couple of other days before that, a match. When you light it and it burns off, it's going to give off energy as light and heat. Like matter, energy is conserved. Remember, we learned that means to save or to preserve or to hold on to, so we can mark that. Conserved. So that's saved. In a chemical change. Energy is never created or destroyed. It can only be transformed from one form to another. Temperature and thermal energy. Think of how it feels when you walk inside an air-conditioned building from the outdoors on a hot day. Whew, what a difference in temperature. Temperature is a measure of how hot or cold something is. It's related to the energy of motion of the particles of matter. The particles of the gas in the warm outside air have greater average energy of motion than the particles of air inside the cool building. We've talked about, and you learned during the e-learning day, that when things are in a gas, the particles are spread out and they're moving super fast. A liquid, they're a little bit slower, but they're still sliding and gliding past each other. And then in a solid, they're in some sort of solid pattern form where they're just vibrating. Thermal energy is the total energy of the motion of all of the particles in an object. Usually, you experience thermal energy when you describe matter as feeling hot or cold. So thermal, if you've ever heard of like thermal gear or a thermos. Temperature and thermal energy are not the same thing, but the amount of total energy that an object has is related to its temperature. So the more thermal energy an object has, the warmer it is, and the less thermal energy it has, the cooler it is. Thermal energy naturally flows from warmer matter to cooler matter. So I think what I'm going to mark here is the amount of thermal energy an object has is related to its temperature. I think I'm going to mark that more is hotter and less is cooler. Okay. And then also another thing that's very important here is that thermal energy naturally flows from warmer matter to cooler matter. What this tells me is that if I were to hold a snowball in my hand and it melts, the interesting thing is the snowball doesn't melt or really, it doesn't feel cold in my hand because it's cold. The reason why a snowball feels cold in my hand is because it's taking my heat. I am warmer than the snowball. My thermal energy or my heat energy is going to go in or flow to the snowball because I am warmer. Thermal energy goes from warmer to colder things. Same with an ice pack. I always thought that when I put an ice pack in my lunchbox that it kept it cold because the ice was cold, and so it just made everything cold. It gave all of its coldness to my stuff, and that's why it melted by the end of the day. When in actuality, the reason why my ice pack keeps things cold and the reason why my ice pack is melted by the end of the day is because it's actually absorbing the heat. Any heat that's trying to get to my food, it's absorbing into it. And as it's absorbing that thermal energy or heat, it's going to end up melting. But thankfully, it's keeping my food cold because it's keeping all of that warmth away from my food. The thermal energy goes from warmer to colder. When you get into a bathtub, the water is warmer than you are. It goes from warmer to colder. So the reason that you warm up is because that warm water is going to warm you up. Hopefully that makes sense.